Welcome. In this video I'm going to show you how you can perform an exact multinomial goodness of fit test using Python and my stikpetP library. If you don't want to use my library, I have a separate video over here where I'm not using it. The Python version I'm using is 3.9.7 and I'm using JupyterLab, but this code should also work in any other IDE. I'm going to focus on how to obtain the results and not how to interpret them, or if you should even be using them. To show you how this is done, I'll need some example data. For that, I'll first load in my pandas. You can install pandas with pip install, but that way I can use the read CSV function and load a file known as GSS2012A, which is from the General Social Survey from 2012, and I slightly adapted it for the purpose of some other examples. I don't need all the data, I actually only need the marital status or any other nominal field, so let's use that one. As you can see with values counts, there are quite a lot of people married. I'm actually just not going to use all of these because this function will take a really long time to load, so I'm going to sample the data a little bit. I'm just going to randomly sample 15 instead of using all of them. As you can see, it still has married as the top, and we actually have less categories now. So apparently separated wasn't in this random sample. Now to use my library, you'll need to install it first. You can use pip install and then use this entire link because it's not directly available via the usual ways. And then you can import it just as any other library. The function of interest is TS, for short for test, multinomial, and then GOF for goodness of fit. It takes as input parameter, of course, the data, and if you want, you can also specify what the expected count should be. So let's take it for a spin, and in this case, as you can see, the observed probability is the probability for this specific count. It has done 816 different combinations, and the probability for something like this, or even more extreme, so more rare, is 0.05. That's just above the usual 0.05 threshold, so we would not reject the null hypothesis. So in the population, it could still be that the frequencies are the same across all categories. However, if we would take a larger sample size, it might actually change. If you're interested, you can also specify your own expected count, so then do that as a data frame, actually as a dictionary, as a data frame with the categories and of course the expected counts, and then you can feed that as the as those expected counts, and it will simply run the test and gives you the same output with different results, of course. If you don't want to use my function, you can follow the formula. Like I mentioned, I have a separate video on how to do all of this. So hopefully my function in my library actually makes it slightly easier, then you don't have to do all of this. Alright, well, I hope this video was helpful and thank you for watching.